Hello and welcome back to the Age of Gaming. In this episode we are going to load the mini program C from the first book of KIM. The mini program C will display the values that we program onto the 6-7 segment displays. The KIM-1 monitor program has several subroutines that you can call on to do certain functions like display things on the 7-segment displays. One of those subroutines is called SCANDS and is used to do just that. When you call SCANDS by using JSR, jump to subroutine, 1F1F, the 6-7 segment displays will light up for a brief second and display the contents of address 00FB, 00FA, and 00F9. You need to know that when you do call SCANDS, the contents of your registers will be wiped out. So if you have something in any of the CPU registers that you want to keep, be sure to store them somewhere in memory so that you can recall them when needed. Okay, I think we're going to be able to get through this program pretty quickly. So let's get started and let's look to see what we can do with the scan subroutine. Okay, let's start up the KIM-1 here. And as always, first thing we're going to do is go to address 17FA and data 00, 1C, 00, 1C to set our reset vectors. And I guess we'll just go to address 0200 and start loading this program up. Okay, the first thing we're going to do is go to address 200. First thing we're going to do is A9, which is LDA with the 00. Then we're going to do an 85, which is store A at FB, plus we're going to store it at FA, plus we're going to store it at F9. And then we're going to jump the subroutine 20 plus 1F plus 1F, and then just loop back to that. 4C is a jump back to 08, 02. Okay, address 0200. Now when we press this, we're going to see all zeros across the board here. Voila! Wow, we have all zeros. How useful is that? Not very. So let's quickly just go through a couple of the exercises here. The first exercise is, can you change the program to make the display show all 5s? Well, yeah, we can. Let's hit stop and go to address 0200. And instead of A900, we're going to change that to 55. And go back to address 0200 and press go. And we got all 5s. Woohoo! The next one is a little bit more complicated, but not much. Can you write a program to make it display the display show 1, 2, 3, 4, 5, 6? Okay, stop, address 0200. Let's see, first thing we're going to want to do is load 1, 2 and store that at FB. Then we're going to A9 plus 3, 4 plus 85 to FA plus A9 plus, what is it, 4, 5, 6 plus 85 plus F9 plus jump to subroutine 1F plus 1 plus, and then what is it, 4C plus, I don't know where we're at now. Let's say 908 plus 02. No, but I want to make sure that's right. Address 0208 is not right. right there. We want to go to 020C, so 020C, data 0C, 02, okay, address 0200, and say go. Oh, there you go, 1, 2, 3, 4, 5, 6. Again, not very impressive, but at least now we know how to get things onto these 7-segment displays. So I wanted to do something a little bit better than just, you know, put some static numbers up there. So I went ahead and wrote a simple program to start incrementing just the seconds here. So let's start doing that and see if we can't build on that. Okay, if you're like me, you might be inspired to do something else with this SCANDS program. My first thought was, what if I just incremented these last 2 digits? That sounded something interesting and might be a challenge. So let's go ahead and do that. So I'm going to go to address 02, oh, it's up. Go to address 0200, and we're going to load A9 and data 00. We're going to store that 85 in FB, and then store that in FA, and store that in F9. So like the very first program, we're putting 0 in all 3 of those registers. Now we're ready to use a new command, which is increment E6 F9. Then A9 plus 00 plus store that in address 71. And you'll find out why we're doing this a little later. And then jump to subroutine 1F plus 1F. And now we'll increment again. We'll increment 71. And load 71 and compare that, 9 to, let's say, 50. And introduce another command here, which is branch if not equal, D0, branch if not equal to F5. And then finally jump for C back to 0, 8 plus 0, 2. Press 0, 200. Well, let's see if this works. There we go, we're counting. But as you can see, we're counting in hexadecimal. And we're counting rather slowly right now. So if I hit stop right now, and I go to address 0217, I think it is. Nope, address 215, 0215. And if I change this to say 20, it'll run a lot faster. So address 0200, and go. You can see it's running a lot faster now. Now this program counts from 0 to FF and then back to 0. So we were successfully able to get our counter to work here. But it's in hexadecimal. Now what do we have to do to get that program to count in decimal? That's a lot more work actually. We're able to do something a little bit more exciting with the SCANDS program than just put static numbers up there. So that inspired us to start counting in decimal. And that's a hard enough job as it is. And let's see. Now I'm going to go to the tape drive. And let's go address 00F1. We're getting ready to do a restore from tape. We want to make sure F1 is set into binary mode. Then we're going to address what is it, 17F9, and put the ID in there, and then just go to address 1873 and press go and play on our recorder. There we go. Stop there. Go to address 0200, and let's see what happens. Oh, we're counting slow again. As you can see, we're counting in decimal. 40, 50, 60, 70, 80, 90, 99, and back to 0. Now this took a lot more work. I'll show you that up here on my screen, what we had to do to get that to work. Okay, let's go over these two programs and see what we were able to do with the SCANDS subroutine. The first program counted from 0 to FF in hex, so it was pretty simple. We did pretty much the same thing as we did in the mini program C. We loaded 00 and the hours and the minutes and the seconds. And now we added a new command, increment, and we increment F9, or the seconds location. And then we load A with 0 and store that 0 in address 71. And then we jump to our SCANDS routine. We increment 71 and load that back into A and compare it to 50 or whatever number we want to use here. This will actually speed up or slow down your count. And we're using 71 as our counter for SCANDS. So after 50 times through the SCANDS, because it's going to branch if not equal to 50, back up here to SCANDS, and it'll keep doing that 50 times. And then finally when it's done, it'll come down here and go back up to increment F9 again. So it's going to basically count from 0 to FF all the way through the hex and then back to 0. So that was a pretty simple program that we use the SCANDS routine. Now if we want to, convert that into decimal, turn this hex into decimal, that's, as you can see, a little bit more complex. So pretty much we start off the same. We're loading everything with zeros up here. But we're starting F9 at FF here because we're going to increment F9 to 0 on the first count before we ever get down to the display section. So, and then we're going to start address 70 at FF before the first increment 2. We're using address 70 as a counter for to count from 1 to 10 and let us know that, okay, you're at 10, now we have to actually come down here and increment F9 like 5 times, actually 6 times if you count 0. So it goes from A, B, C, D, E, and F, and then it's ready for 1, 0. So it will go from 9 to 1, 0. So again, here we increment F9 for the first time, use 70 as to count up to 10. Here we're testing to see if it is 10. If it's not, we're going to branch down to display and display whatever number's in F9. If it is, then we're going to come down here and we're going to reuse 70 and increment F9 5 times so that it goes from 0, 9 to 10 in hex. And the key to that is this, 70. And our display is pretty much the same as it was before. We're using 71 as a counter. Here's our SCANDS subroutine. We're just incrementing 71 as many times as we want. We have 50 in here. We could make that 20 to make it run faster. And we're just going to keep looping there so that the display stays up on the screen. And after it hits 20, it's going to come down here. We're going to load 79 in, check to see if that reached 99 yet. If it didn't reach 99, we're going to jump back to 02 for E, which is basically just back up here to our loop and count the next number. If it is 99, we're going to start the whole program over at 00. And that's it. I mean, it looks more complicated than it actually is, or maybe it's looks easier than it actually is. I'm not sure. Anyhow, let's go on and see what we can do after this. Next, I want to be able to increment the minutes, so we can have the seconds and the minutes working together. So stay tuned for that.